Hi everyone. In today's lesson we are going to continue talking about function. This time we're going to start with properties of a function. Now there are multiple properties that we can look considering a function. And let's start with the first thing that we can look at, and that is going to be increasing, decreasing intervals, or where the function or when the function values are going to increase or decrease. Now, in this here example, I have drawn a graph of a function f. Now, of course, this is not any specific function. This is a combination of multiple functions considering the intervals. So you can be asked something like that, for example, in written assessment. You may be asked something like this in a state exam. So let's see how we are going to solve this situation. So if I want to talk about increasing, decreasing values of a function, it's simple enough as I stated here, and I'm going to mark it now again. F of x values are increasing for x's element. Now we have to determine for what x's they are going to increase. Now, if you take a look at the whole picture here, there is only one situation where values of the function are increasing, and this is, if you look at the graph here, from -1 to 4. So this is the situation that's going on. Here the values of the function are increasing. So we're going from value -1, y, to value 4, looking at the y, and continuous increasing, even though here you have a little stop, so to say, but it still continues to increase before and this after point. So what can I write down? Well, this is going to be f of x values are increasing for x element from 1 to 4. Now you can ask, of course, why are we not including 1 or 4 in all of this? Well, look at the value 4 and its point is 4, 4 point in coordinate system. We can mark it 4, 4. Well, what's going on here? Well, situation is before it, the values are increasing. After values are starting to decrease. So what are we going to say? We are going to basically say that this here exact value is not included in neither the first part nor the second part, because here we don't have any movement, so to say. And this type of point is going to be called stationary point. Now, remember when we talked about quadratic function, and there we had a situation where a certain point, aka vertex, was stationary point, because before it and after it, we had a change of state, increasing, decreasing, so to say. Now, of course, we can look at the other situation, that is the decreasing situation. So f of x are decreasing for x element. Now, when we talk about the intervals, we want to start from the beginning, from the left to right. Now, if you take a closer look, there are a couple of situations where the values of the function are decreasing. So first we have this part of the graph. Now then we have this part of the graph, and in the end we have this also part of the graph. So basically 3 intervals. Now these 3 intervals go from -infinity to -2 excluded. This is first part. Second part should be from 4 to 6. And the last part should be from 7 onwards, if you take a look at it like that. Now, since we talked about domain and range, this is quite a similar talk. Now, when we talk about domain, I want to define what the values x can be for the given function and its formula. In this here case, I'm looking at the parts of the domain for which values of the function are decreasing or increasing, each of its own. Now let's mark it all down. So x is element from -infinity to -2 excluded, union, because x is going to be either in this part of the set or this part of the set or the last part of the set. So from 4 till 6 both excluded, union from 7 excluded to +infinity. And this is it. Now, of course, there is a last situation that I haven't marked so far, especially, but we still have to talk about it. And I haven't even specified it in the title of this here lesson. Now, this is when the function is stagnant. Basically, there is no change in values. Now, if you take a closer look at this here picture, there is certain part, for example, from -2 to 1, where values of function are constant. And same thing goes from 6 to 7. They are constant. Now, of course, you can mark it. So let's say f of x. Look at how I've shown it as the arrow that is horizontal arrow, so to say. Basically, the values are not changing. They are constant. And this is from for x's element. First of all, we are talking about interval between -2 and 1. And then from 6 till 7. So let's write it down. So -2 till 1, union from 6 till 7. And there you go. Now, I'm not going to give you any more examples of this. This should be simple enough to determine when you look at the graph that's given. And considering the graph, you can determine what we did in this task. But you can expect it definitely in written assessment, and you might even expect it on state exam. So do not forget about this. Now, of course, we want to also use this for functions that we did learn the past term and at the beginning of this term. So let's look at a couple of tasks themselves. So what are we going to do? I'm going to write here the task. So task and a couple of examples, A, B, and C. So let's write them down. So A is going to be with function A, where A of x is equal to -2 times square root of x plus 5 and plus 1. Then B function is going to be B of x equals to 11 over x plus 1 minus 6. And the last function is going to be C function. C of x is equal to 5x squared minus 2x and plus 3. Here we go. So 3 functions for the exercise where we can look at the values increasing or decreasing. Now, I'm going to expand all of this with something else, but more about it a little bit later. Let's go step by step. Now, I'm not going to go into detail for all of these tasks. I'm going to show you for A and B just the idea of it. So let's start with A. The best way to determine values of increase, decrease, in my personal opinion, is graphically. So if you know how the graph looks like, if you can sketch it in coordinate system, quick draw it basically, then you're certain of what's going on, and then you have the proof or explanation for me what is going on and how you concluded what you did. So let's start with function A. Of course, try to sketch each of these functions on your own, and then take a look here in this video whether you did it correctly or not. So what I can immediately say, it's 5 to the left, 1 upwards, and it is turned upside down, meaning it goes from left to bottom right, so to say. So let's say -5 is here. This is just the sketch itself, and here is the one. This is not the quick draw as it should be. And the curve, as I said, is downwards curve that goes like this. Now, if I want to talk about increase, decrease, or stagnant, I'm just going to write down what we actually have. Now, if you take a closer look in this here picture, what we actually have in this here situation for the for irrational function is that, well, it is going to be continuously decreasing throughout its whole domain. So we can also say that this function is strictly decreasing function. So we can also mark it if the values are decreasing. We can just write down that not f of x, now in this case a of x, values are decreasing for x element. Now we basically write down the domain. Now in this here case, we can actually include the edge or the beginning, so to say, of this curve and everything after it. So from -5 to plus infinity, where -5 is included. You don't have to mark for what is going on with a of x is increasing, because there is no increasing part for this function, and you don't have to write anything for the a of x is stagnant, because we don't have anything stagnant in this curve or the function itself. You are done considering the a function. Let's talk about the b function, reciprocal function. Now in this here case, of course, the graph is going to be hyperbola. And whenever we talk about hyperbola, it means that we have to also sketch the asymptotes, horizontal and vertical asymptote. So don't forget about that. Now, considering that, well, 1 to the left, 6 downwards. Let's say here is -6 and here is -1. Now I'm going to sketch the asymptotes. Just want to be precise as possible. Here we go. And now I can sketch the hyperbola. Now what's going on here? Well, if you take a closer look at this here function, similar to the function a, we can differentiate two parts of the hyperbola, left and right, so to say, bottom left, top right. Now, if you take a closer look at what's going on, we are going from -infinity to +infinity concerning the axis. What's happening on the curve, meanwhile, where it looks like it's stagnant at the beginning, but it's not. It's always going to be decreasing, 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 and continues decreasing to -infinity. Same on the right side, top right side. Decreasing, 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 decreasing all the way to -6, but it's going to decrease the whole time. So both on the left and the right side, the values of the function are decreasing. So similar to function A, with function B, we have to mark that B of x's are just decreasing. 4. Now we can say that x's are also elements of the domain, because the whole domain, for the whole domain, and this function is too strictly decreasing in this here case. So x's are elements of real set, just without what we have to exclude. It's the -1. You can also take a look at it graphically. And there you go. Now for the C function, aka quadratic function, I'm not going to sketch it. I'm going to leave it up to you. But unlike A and B, this time we're going to have both decreasing values and increasing values. So they're going to be interval of x's for decrease and for increase. So watch out for that. Now, one thing I can add to all this properties situation considering the function. Now, you can also look at the function and its minimum maximum values, of course. And you can look at the local minimum or maximum and global minimum and maximum. Now I'm not going to write it down here, but yeah, basically we have two ideas, min and max. So I'm going to just write the idea of min and max, and two ways we can look at it, globally and locally. Now if you take a picture at the beginning of this here function and its graph, globally when we look at it, well, we see that the functions where we are in -infinity for the x's are in +infinity values of the functions. While where we go to +infinity on the axis, the values of the function itself are going to -infinity, meaning globally we do not have minimum or maximum. Now we have to write it down. Well, I'm going to write it down here. You can write it down normally on the side. Well, here the maximum of function f is +infinity, meaning it doesn't exist. So you should write down it doesn't exist. If it was an actual value, well, then you would write this value down. In this here case, since it's +infinity, well, it doesn't exist. It doesn't exist. Now, in the meantime, on the right side, the minimum value, it looks like it goes towards -infinity. Again, because of that, it doesn't exist. Now, what is an example where we actually have minimum or maximum value? Let's take a look at the function a. Now, if you take a look at this here point, well, this here point is certainly the highest point considering all the others on the curve, meaning, well, here is where the maximum value lies. So here is the maximum. Now, of course, the maximum value of the function is its y value. So we are looking at the values of the function, and we are looking at the maximum. So maximum value should be, so max of function of a is 1. And this is it. So 1 is the maximum value. Meantime, for the b function, again, plus infinity, minus infinity, we don't have minimum or maximum value. Now, watch out, for c function, there is going to be minimum value, just like, let's make a sketch on the side. So it's parabola, here is the vertex. Well, in the vertex, if you look at the coordinate system, well, this is going to be its y0 value. So x0, y0. So y0 value calculated, and this is going to be the minimum. Now, let's look at the local situations. Now, local situations, when you give them, they're between certain intervals. And I'm not going to fuss you about them that much. I'm going to generally ask you for the global ones. We are going to get to the local ones in the 4th grade, but just so you get an idea what's going on. I'm going to go back to the sketch that I've already drawn of function f. So let's take a look at here. Let's look at the interval from 1 to 7. So from 1 to 7, I'm looking at this here part of the graph. So this is basically it. The ascending line, a curve, sorry, then descending curve, and then stagnant curve. So this is the part that I'm actually, well, I can mark it so that we know what's going on. So this is the one I'm looking for in all of this. So if I ask you what is the minimum value, well, you're going to say, here is the minimum value, it's the lowest point, and minimum value is -1. On the other hand, when I ask you what is the highest value or the maximum value, well, here is the highest point in the whole part of this graph, and it is, so max is 4. Now, of course, this isn't this 4 on the x-axis. This is where this maximum is. Here is the 4, meaning the value of the function itself. So this is the maximum, this is the minimum, so -1. So watch out for that. We're always looking at the y values for considering the minimum maximum. Now, one more thing I can ask you is where this maximum or minimum is. Now, this local minimum is in 1, and local maximum is in 4. Same goes for the function a. So we have just the maximum. Where is it? It is for x equals to -5. Write this down. For x equals to -5. Here is for x equals to 1, and here is for x equals to 4. And this is basically it. Now, your homework task is to mark, of course, minimum maximum for function c, and intervals of increase decrease, of course, and that's pretty much it. See you guys in the next one. Bye.